Welcome back, team. Today we are diving into extended thinking mode, a game-changing feature for high-stakes decision-making. Let's get started. Welcome, everyone. Today we are tackling extended thinking mode, a crucial tool for high-stakes decision-making. Think about how you solve a complex problem. You don't just blurt out the first word that comes to mind. You pause, outline the steps, and deliberate. Standard language models usually just predict the next word immediately. Extended thinking changes this by giving Claude an internal scratchpad to work through its logic, math, or coding problems step by step before it delivers the final answer. We activate this via the API, which completely transforms the accuracy of your results. By incorporating these deep reasoning insights before writing the final output, Claude acts less like a chatbot and more like a senior analyst. Let's look at this flowchart to visualize the difference. On the top path, a standard model takes your prompt and immediately generates an answer. This is fast, but risky for complex tasks. On the bottom path, extended thinking introduces a crucial middle step, the internal reasoning block. Here, the model generates thinking tokens to explore the problem thoroughly before moving to the final node, generating a highly accurate answer. Now, how do we actually tell Claude to think? In the past, developers had to manually guess how many tokens Claude might need to solve a problem by setting a hard budget. This was incredibly inefficient. Enter adaptive thinking. Adaptive thinking lets Claude dynamically determine exactly when and how much to use extended thinking based purely on the complexity of your specific request. If you're using Claude Opus 4.7, adaptive thinking is actually the only supported mode, completely replacing the manual token budgets. You simply pass the type as adaptive in your API payload, and Claude handles the heavy lifting, ensuring it doesn't overthink simple questions or underthink complex architectures. This state diagram shows the beauty of adaptive thinking. When your API request specifies the adaptive type, the model evaluates task complexity on the fly. If the task is simple, it transitions to minimal thinking to save time and money. If it's a complex, high-stakes decision, it transitions to deep reasoning. Both paths converge on optimal token usage, meaning you get the exact right amount of brainpower for the job without micromanaging budgets. If adaptive thinking is automatic, do we have any control over the depth? Yes, through the effort parameter. This parameter acts as soft guidance, telling Claude how eager it should be to spend tokens on reasoning. It ranges from low for simple tasks where speed matters up to max for unconstrained thinking depth. By default, the API uses high effort, which provides a great balance. But here is the pro tip: for long-horizon agentic workloads and complex coding, you should set the effort to high. This tells Claude to engage in extended exploration. We only use max for frontier, previously unsolved problems, because it can lead to overthinking and higher costs on standard tasks. This mind map breaks down your effort parameter options. Moving clockwise from the top left, low is for speed-optimized, simple tasks. Medium is your cost-sensitive middle ground. High is the default balance. Dropping down to the bottom right, high is your go-to for coding and agents. Finally, max is reserved purely for high-stakes, frontier problems where you want zero constraints on token spending. Let's look at the actual code implementation. To trigger this properly, you must configure your JSON payload correctly to avoid API errors. You add the thinking object at the top level of your request, setting the type to adaptive, and alongside it, you define your effort level, like high. But here is a critical deep dive. When you tell Claude to think deeply, it's going to generate a lot of internal text. If you leave your max tokens parameter set to something small, like 1000, Claude will hit that ceiling while it's still thinking, cutting off your response prematurely. Always set a generous, max tokens budget, like 64,000, when using high or max effort so the model has enough room to operate. This sequence diagram illustrates the perfect API call. The app sends a post request to the messages endpoint. Notice the payload in the center note. We specify the Opus 4.7 model, a massive max tokens limit of 64,000 to give it room to breathe, the adaptive thinking object, and the high effort parameter. The API then streams back both the internal thinking blocks and the final text response seamlessly. Once Claude does all this thinking, do you actually see it? That depends on your display configuration. You can set display to summarized to see a summary of the reasoning, or omit it to hide it completely. Why omit it? If you are building an app for end users, streaming raw thoughts adds latency and bandwidth overhead that the user doesn't need to see. But pay close attention to the billing. You are charged for the full thinking tokens that Claude generates internally, regardless of whether you omit them or summarize them. Your build tokens will be higher than the visible text tokens you receive back in your JSON payload. You are paying for the cognitive labor, not just the text delivered over the wire. Look at this billing flow closely. Claude generates 5,000 internal reasoning tokens. Based on your display setting, it might send 500 tokens back if summarized or 0 tokens back if omitted. However, both of these paths lead to the red node on the right. You are billed for the full 5,000 tokens of compute used. Now we combine extended thinking with tool use, unlocking interleave thinking. When adaptive thinking is on, Claude can pause, use a tool, look at the result, and think again about what to do next. This is mandatory for complex agentic workflows. But there is a strict rule you must follow. When you send tool results back to the Claude API, you must include the complete, unmodified thinking blocks from Claude's previous turn. Why? Because Claude uses those blocks to remember its train of thought. The API actually attaches cryptographic signatures to these blocks, so if you try to edit Claude's thoughts or drop them, the API will reject your request with an error. This sequence diagram maps out interleaved thinking. The agent sends a prompt. Claude returns thinking block 1 and requests a tool. The agent executes the tool. Now, look closely at the next arrow. The agent sends the result back to Claude, but it also attaches the exact, unmodified thinking block 1. Claude ingests this, continues its reasoning in thinking block 2, and finally delivers the final answer. Let's apply this to a real-time, high-stakes use case, a merger and acquisition financial audit. You feed 500 pages of corporate disclosures into your application. A standard AI model would just skim this and give you a generic summary, completely missing buried liabilities. But we are professionals. We trigger Claude Opus 4.7, set thinking to adaptive, and crank the effort to high. Claude uses interleave thinking. It searches your database, reads a debt table, pauses to reason through the accounting practices in its hidden scratchpad, realizes the math doesn't align, and flags a massive hidden liability. By forcing the model to deliberate step-by-step before answering, you just saved your firm millions of dollars. Follow this high-stakes flowchart. The massive financial PDF goes into Opus 4.7 running at high effort. It enters the interleave thinking loop, extracting tables and reasoning heavily through the accounting math. Because it has the token budget to actually deliberate, it hits our decision diamond and successfully spots the discrepancy. It branches left to the red node, flagging a high-stakes risk that a fast, non-thinking model would have entirely overlooked. To wrap up, extended thinking is powerful, but you must follow best practices. Don't micromanage the model, give it general instructions and let it think, rather than forcing it through your own rigid step-by-step prompt chains. Claude's adaptive reasoning will often find better paths than we can prescribe. Reserve high and max effort for truly difficult tasks to avoid wasting time and money. And keep an eye on your context window, as retaining all those thinking blocks will fill it up faster. Master these tools, and you will build extraordinarily reliable AI agents. Finally, I invite learners to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. This final mind map summarizes your path to mastery. Master your settings by defaulting to adaptive mode and high effort for complex work. Master tool use by embracing interleaved logic and rigidly preserving those thinking blocks when posting results. Master your tokens by providing a high max token ceiling and understanding the nuances of output billing. Thank you for joining me and happy building!